Okay, so we're trying to find the equation of the tangent line to this guy, and the equation isn't defined implicitly for y, so we can use implicit differentiation here by getting the derivative of both sides. So here on the left, well, we have to use the product rule. So what we would have, remember, is the derivative of the first times the second, leaving it alone, plus the first, leaving it alone, times the derivative of the second, which is just 2y times y prime. And this is going to equal to 0. Okay, so if we solve for y prime, we would get y prime is equal to negative y squared over 2xy, just by moving the y squared over and then dividing both sides by the 2x and the y. Okay, and so then to find the tangent line, remember what we need is two things. We need the slope, and to find the slope we need to plug in the point into my derivative. So to find the slope, I need to grab my derivative, and I need to plug in the y value that I have, which is this guy, and I need to plug in the x value. And so if I do that, I'm going to get on the numerator, I'm going to get negative 1 over negative 2. Or in other words, the slope of the line is equal to 1/2. Okay, and then the second part is I need my y-intercept. And so I have my equation of a line, y equals mx plus b. And I write down what I have. So far what I have is that y is equal to negative 1, my slope is equal to 1/2, and the x value is equal to positive 1. And so this means that b, if I solve for it, this is going to be negative 1 and then minus another half, so it's going to be negative 3/2. Okay, and so in the end, my equation of the tangent line is y equals 1/2 x minus 3 over 2. And that's it. Okay, so here we're trying to find all the points on this graph where the tangent line is horizontal. So what we're basically looking for is the places where the derivative is equal to 0. So this is a little tricky, but let's start off. So the first thing is, well, we know we need the derivative, so why don't we find that? Now this is a implicit equation, so let me write it out again. And we're going to get the derivative of both sides. Okay, and so the derivative of this guy is going to be 6x plus, here we have to use the chain rule, so this is going to be 8y times y prime plus 3. Here we have to use the product rule, so it would be the derivative of the first, which is 1, times the second, plus the first, leaving it alone, times the derivative of the second, which is y prime. And this is equal to 0. Okay, so now if we solve for y prime, what we're going to get is that y prime, if I move the 6x and the 3y over, this would be minus 6x minus 3y over 8y plus 3x. Okay, so here I'm basically looking for where is this guy going to equal 0. So I'm not really worried about the denominator here. What I'm really worried at is about the numerator. When is this guy equal to 0? Well, this guy is equal to 0 anytime that y is equal to negative 2 times x. And so, well, you might be wondering, well, then how do we find the x values? I mean, we know that this is true, that the derivative of 0 when y is equal to negative 2x, but those aren't the actual values. Well, but you do have this relationship. You have the original equation. So if you substitute back into the original equation, you should be able to find what x has to equal. And so what we have is that 3x squared plus 4. Now here, instead of y, I'm going to do negative 2x squared plus 3x. Now instead of y, I'm going to put negative 2x is equal to 24. And so now what I have is an equation that I can actually solve. So here, let me just clean this up a little bit. This is 3x squared plus 2x squared. Well, that's 4x squared times 4 is 16x squared minus 6x squared equals 24. And now I'm getting somewhere. I have this guy is equal to 13x squared equals 24. Divide by 13, and I get that x is equal to plus and minus the square root of 24 over 13. Okay, and then to find the y values, well, that's easy because I know y is equal to negative 2x, so if x is equal to positive square root of 24 over 13, y is equal to negative 2 times the square root of 24 over 13. We'll call this y1, and then the second one would be positive 2 square root of 24 over 13. So here we have two x values and two y values. So if I write them down as points, they would be when x is positive square root of 24 over 13, y is going to be negative 2 square root of 24 over 13. And then the other point would be when x is negative square root of 24 over 13, y is going to be positive 2 square root of 24 over 13. And that's it.